Okay, so we're going to continue on with modifying targets and doing some more configurations. So I'm going to move out here and I'm going to go to my other part. So Home tab, make this part visible, right click V, and make that part invisible, whoops, that part invisible. And then I'm also going to change the path that I'm welding. Okay, so I'm going to change this thing now from being welded in the horizontal position to being welded in the flat position. So what I want to do is I want to weld this, modify joint external axis. I'm going to start out going present and then just moving this to 270. Seems about right. So apply. So then here I've got to go more positive. So, oops, jump to there, oops. There we go. Now that's right. So 270, and so then I'm going to go present and make sure I'm going the right direction. So go 270. And then go 360 around. So each time it clicks, it's going to go 45. If it's not on fine tune. If it's on fine tune, it'll go 5. And when it's not on fine tune, if I click here, it's going 45, and here it's going 5. When I'm not on fine tune, if I click here, it's going 5, and here it's going 1. So then apply. So then, to get so that all of the external axes are the same, or so that it spins around correctly after I've created the path, I can shift, click to the endpoint, and I'll go right click and go modify, optimize selected targets, and what I want to do is go interpolate external axes. So check this out, make sure the numbers make sense, go from -45, say that stays, and that stays there, and just hit apply. I usually just guess and then see if I go the right way, and if it ends up going the wrong way, then I chose wrong. So there we go, I guessed right, and things go the right way. Okay, so then here I'm going to make sure this one does the same thing. I'm going to modify joint external axis, go present, apply, and then I'm just going to jump to here, I'll move to there, and go here, present, apply, and do the same thing to optimize these targets. Now I'm going reverse, 630 to 270, and apply, and then move to the points. Now if I don't have that many axis values here, I can go 360 less than that, and then make that 360 less as well, and it should all work out just fine. So that's a quick way of modifying a bunch of external axis values and interpolating them from one point to another point. Usually and most often used on circles. You can also use them on other shapes as well, but circles is the most common and it's most effective when you do that. So if I want to modify my torch orientation, so say, hey, you know what, this torch I don't want to be facing like this. Some clients, because I know that the cast on the wire, odds are that it's going to come down from that bend there, and it's going to be coming and kind of pointing back towards the torch, depending on how it's in the wire bell. There's a lot of things that could affect it, but some people say, hey, you know what, we want our torch nozzle or our wire, our nozzles, oops, I have to select an individual target, not a whole set of targets. I want them always being facing like this, so I'll make that 180. I can either type it in or slide the dragger ball, the slider bar all the way across. Move to that point, make sure it looks good, and then I can go individually point by point and adjust this. Or if I say, hey, you know what, I need a push angle in there as well of 10 degrees. There we go, 10 degrees there. We want to make this 47 for whatever reason. Apply. I want to just double check that. Yeah. So if you had interference here, if this was longer and you said, hey, we need to slightly adjust that so we're not going to have interference, I'm going to do that. And so we go apply. so I changed that to 43, just pretending that I've got interference there. So then I can go through and say, okay, you know what, now I've got this set up, so I need to go through and make sure all of the targets have the same thing. I can go point by point, adjust it, apply, adjust it, apply. And on the circular points, you only have to do this end point, you don't have to actually have to do the middle point. And so then move through here, and it's already adjusted. But faster way to do it is Shift, select the whole thing, right click, modify, target offset angle on selection. And since this blue point right here is the darker blue point, is the one that I have selected, all of those are automatically populated and updated. So then I hit OK. And one thing I like to do, especially when doing a lot of the welds that I do, is I'll go through and so let's just go through and watch how that moves. I'll go through and offset all of my targets in the Y and Z. It's just so that they're up out of the joint. So that way when I go through and step through the program, they're not going to hit they're not going to be anywhere near my part. So I'll go for 5 and 5, we'll just say. And this is 5 millimeters and 5 millimeters. And then hit apply. And you can see how that moves up a little bit. And so then I'll go through and Shift and do that for all of the targets. And you can use that same thing. And you can deselect, hey, I don't want to check the angle anymore, I just want to do that. And hit apply. And then same here. And I only leave my first point with the uncorrected values. So the first point is the one I won't go through and edit the offset values, because I want to see how good the actual program is online to offline, and I want to see how close it actually comes in. And if I've decided, hey, you know what, I know these programs well enough, I know that a 5 millimeter offset's fine, since I know that I'm going to be tracking this, I'm not going to worry about it. I'll let the robot bring the torch into where it needs to be, and so then when I step through the part or step through the program, I'm just stepping through. I'm not going to worry about if they've got any tacks in there. I'm not going to bend my wire. There's a lot of reasons why it's a good idea to do that. But mostly it's a programming preference that I have. So I'm going to do the same thing here. And here it might be a different direction. So this is actually looking like it is going to be 5 and 5 as well. And so I'm choosing 5 and 5 based off of this X or this Z and Y direction there. And if I choose wrong, sometimes it might be -5 and +5, or it might be +5 and -5. Depends upon what the direction is and how things look. Modify target offset angle. I only want to do that, and hit OK. And you can see how the path now, the blue line, is away from the part. Okay, so that is how I go through and modify multiple different points and areas all at the same time. So let's see if move to failed. So I'm going to see if I've got some other configurations possible in reaching this target. It might not be. So I'm going to go through here and go modify or change the configuration on this. See what other configurations I have available for me. So yeah, here's the configurations are. Here we go. So now, as we go through and change this setting here, you can see how these configurations can change things. This one doesn't have that many. Some of them, the robot could be down here. But what this does, you can see, look here, you can see that axis 1 is -1 or is +160. And then these are the other axis values to be able to reach these points. So these are all the robot configurations that are possible to reach that one point. So usually we like the robot facing forward, that's not reaching back on itself like any of this. Usually that's not good. This is a bad configuration. You'd never really want to use that unless you're working at a robot that's inverted. That is inverted. Because you have your wire feeder here, it just makes things a hassle. So we like nice, easy reaches to be able to reach things. And then that's where these arms, elbow, wrist forward, ABB up, and neutral as you can. and then apply. So that's a little bit about configurations. Mess around with them, see what you like, see what things do. You can only set configurations on J moves, not on any L moves. So that is circular moves, modifying different paths. Now we can shift and select this whole thing. We can jump to all these points, and as you jump to all these points, a configuration will be set. It may not be this configuration, the configuration that you had set here. It'll be some random configuration. This torch looks a little off because there's a slight error in the system here, but and it's just a lag and delay of how this jumping works on this system in Robot Studio. But now I move to, so this sets a configuration, but it might not be the right configuration. So then here, and if a target's not moved to at all, if they're all white, there's no configuration set, and it uses a default value, which is usually, I think it's 0001. These configuration values that I said, 0001, are in reference to the, and that is how Rapid uses to set the robot quadrants. So here is each quadrant, you got 4 quadrants here, and the quadrants here, to be able to set the configurations. So it basically just tells you, hey, this is how you're using to set this quadrant, to set how the robot looks when it reaches that point. To be able to set the configuration for all of the points, you have to shift from the first point to the end point and move through all the points, and then they'll become green, and then set the right configuration for the whole thing. And that all of these points will be using this same configuration to get through these points. And that's the end of configurations and modifying points and targets for circulars.